We are Mario Rodríguez, Janina Quintero, Diego Velez, and Rene Capin. And this is our project. We chose the TikToks, and the color white has 61 TikToks, and the color pink has 71, and in total it has 132. And this is our evidence. The problem one says if a candy is randomly removed from the package, what is the probability that is color one? Well, you need to divide 15.25 divided into 33, that equals 46.21%. In problem 2, if a candy is randomly removed from the package, what is the probability that is not color 1? Well, is 17.75 divided by 33, that equals 53.78%. If a candy is randomly removed from the package, what is the probability that it is color 2? The probability is 71 divided by 132, that equals 53.78%. Build a general probability relationship by looking at the preceding questions. This is our probability relationship. Color 1 has 61 and color 2 has 71. In total, it has 132.
If a candy is randomly removed from the package, what is the probability that it's going to be candy number 1 or candy number 2? So in this case, you have to add both of the probabilities, which is going to be 61 over 132 plus 71 over 132, which is equal to 100%. And the next one is, if you randomly take a piece of candy out of the package and eat it, what's the probability that when taking a second piece of candy, it's candy number 1, since the one you ate was candy number 2? So you have to multiply 71 over 132 times 76 over 131, which is equal to 25.04%.
Hello, now we are on the page number 7, and as you can appreciate in here, we have some exercises as the one Janina mentioned in her part. So I'm going to explain it. First, we have, if you randomly take a candy out of the package and return it, what is the probability that when you take out a second candy, it is C1 since the one you returned was C2? Okay, this may be sound a little confusing, but when you do the chart and you analyze the probabilities, we have that it will be the probabilities we have divided by the total, okay, and the number of second opportunities we can have, and it gives us a result of 53.78% of 100. Next, if two candies are drawn at random, one followed by the other without returning the first, what is the probability that the first is C1 and second is C1? This is a lot easier because here it needs to be two of the same, so it will be less counted between one. First we have 132 and then we have 131 because one is rested, and the answer is 21.16% out of 100. Now we have other two problems. If two candies are drawn at random, one followed by the other, the same as the other one, but with C8, it's the same explanation that states that first it will be the bag with 132, and next will be the bag with 131. Also, I forgot to mention the numerator also changes because we're talking about C2, and in the other exercise was about C1. So in this case of C2, first we have 71, and now we have 70. So the answer will be 28.74% out of 100. And if two candies are drawn at random, one followed by the other, and without returning the first, we need to retain it. What is the probability that the first is C1 and second is C2? Now what we have is that we have one of each one, and the past was C1 and C1, C2 and C2, so now it's mixed. So what we have is a smaller percentage of what we actually have, but rested, because first we have less in the numerator, and then it's multiplied by the second one, which is added. It's something added, and then we have 33, and next is going to be rested for 32, also multiplied, and we have the answer of 24.18% out of 100, and this will be it. Thank you.
So now we got the discrete random variable distribution table, and in the table you can see the values of x that are 0, 1, and 2, and the probabilities of x that are 0.28, 0.49, and 0.21. Expected value, we got it by multiplying the values of x by the probabilities of x, and then sum them all of them. The variance, we rest the expected value from the values of x, and then elevate them by 2, and then sum them all again, and the result is 0.48. The sample space is C1, C1, then you can get C1, C2, or C2, C1, or C2, or C2. The next diapositive is the tree diagram, and it was pretty simple. We just put C1 and C1, and then getting the two results possible that you can get after you pick that one.